Welcome! In this particular video, we'll be utilizing the law of cosines along with the law of sines to find angles in a specific triangle given the side, the angle, and a side. So let's take a look at our example. Example, find the measure of angle C, round your answer to the nearest tenth. Whenever I see this type of problems, the first piece of advice I would give you is to label the sides. So keep in mind that the side across from angle B, it's side lowercase b. The side across from angle A is what we call side lowercase a. And the side across from angle C is what we refer to as side lowercase c. Now let's identify what we already know. Okay, so let's see what we know. In particular, we already know the length for side BC or side A. Okay, so we have that A is equal to 29 miles. We also know that the length for side AB or side C is 24 miles, so we already know that. So C is equal to 24 miles. And we also know the measure for angle B. So the measure for angle B is equal to 109 degrees. Now, since we're given a side, the angle, and another side, and in this case the angle is included between the two sides, this is a case for the law of cosines. Notice that out of the three original statements, along with their equivalent statements, the one in which we are given the measure of the angle is this one in the middle, where we're taking the cosine of angle B. So we're going to be using this original statement. So I'm going to write that down. So we have that b squared is equal to a squared plus c squared minus 2ac times the cosine of b. However, before I do any substitutions or anything, it's important that we realize what is our ultimate goal. So our goal is to find out what is the measure of angle C. Okay, that's what we want. So looking at this particular equation, we can start to substitute in the information. So we say, well, b squared stays the same because we don't know what b is yet, but we do know what a is. A is 29, so we can say that a squared is just 29 squared plus the c squared. Well, we happen to know that c squared is the same as 24 squared. And then minus 2 times a, which we said was 29, times the c, which we said was 24, times the cosine of b, which we said b will measure 109 degrees. So we have cosine of 109 degrees. However, notice that this is the value for b squared. We want b instead. So to cancel the square, we're going to take the square root on both sides of the equation. And one can conclude here that b is equal to the square root of 29 squared plus 24 squared minus 2 times 29 times 24 times cosine of 109 degrees. But that is what we refer to as the exact solution. Yet, based on the second set of instructions here, they want us to start rounding. So we're going to find an approximation rounded to the nearest tenth. In this particular case, I'm going to be using technology to come up with this approximation. And in particular, I'm going to use the inspires. So I'm going to type in the square root. So I'm going to hit Control x squared so I can activate the square root here. And I'm going to write 29 squared plus 24 squared minus 2 times 29 times 24 times the cosine. Let me hit here a trigonometry cosine of 109 degrees. And before I hit enter or anything else, I need to make sure that I am on degree mode. Notice I already have selected degree mode before, so I'm going to just hit Control Enter. and I get an approximation for my B. I'm going to look at my digit in the tens position and the one after, which happens to be here a 4, which is one of the lowest 5 digits. So I'm going to just round this number to 43.2. So going back to our document here, we can say that B is about 43.2 miles. So let me write that in the diagram. And we go back to recognize what was our goal. Our goal is to find the measure of angle C. Well, this process didn't get us to the measure of angle C. However, if we pay close attention now, we can see that we're given the measure of the angle and the opposite side here when it comes to the B's. We're given the measure of the side across from angle C, and we're looking for the measure of angle C. So this is now a case for the law of sines. So now we can say by the law of sines, we have the following. We have that sine of B over B is equal to sine of C over C. And then substituting information here, the pertinent information, we have that sine of B is the same as sine of 109 degrees divided by B, but B we approximated to be about 43.2 miles, and that is equal to sine of C. We don't know what the value for angle C is yet, so we're going to leave it as it is, over C. Well, it turns out that C is 24 miles, so we can just write the 24 here. Now what we're going to do, we're going to cross multiply. So we can say, well, this gives us the following equivalent statement. So we have 43.2 times sine of C is equal to 24 times sine of 109 degrees. Now, since we want to get the C by itself, I'm going to get my sine by itself. So I'm going to divide by 43.2 on both sides of the equation. And you can note then, because 43.2 divided by 43.2 is 1, and 1 times sine of C, we get the following equivalent statement again. So we get that sine of C is the same as 24 times sine of 109 degrees divided by 43.2. We're closer to the answer now. However, we were looking for the value for C, not sine of C. So we need to cancel this sign. And if you recall, we cancel that by taking sine inverse on both sides. So let's go ahead and take sine inverse on both sides of the equation. So we can say, well, we have sine inverse of sine of C is the same as sine inverse of 24 times sine of 109 degrees divided by 43.2. And once we do this composition here, sine inverse of sine of C just gives us C. So C is equal to sine inverse of 24 times sine of 109 degrees, everything here divided by 43.2. But that is the exact solution. And going back to the instructions, they're actually asking us for an approximation rounded to the nearest tenth. So we're going to use technology one more time, and we can say that C is about, well, let's see. Let's go ahead and enter this into the inspires. So we have sine inverse. So I'm going to go to trig. Oh, let me go back here to my level here. So trig sine inverse of 24 times sine, let me put it all on the lowercase, sine of 109 degrees divided by 43.2. Again, make sure that you are using the degree mode, and I'm going to hit Control Enter here. And I get an approximate value of, rounded to the nearest tenth. I'm going to see here my 6 is in the 10th position, and the number next to it is an 8, which is one of the upper high values when it comes to the digits. So this is about 31.7. So going back to my document, I can say that C is about 31.7. Now, let's put this answer in the context of the problem. C is the measure of the angle. So we can say, therefore, the measure of angle C is equal to 31.7, and we need to specify the units, in this case, degrees. So in conclusion, in this particular video, we have seen how we apply the law of cosines along with the law of sines to find the measure of a missing angle once we were given the side, the angle, and the side in a triangle. So thank you very much for watching. We hope you have enjoyed this particular video, and we would like to wish you a wonderful day.